Now I'm going to do this individual practice problem, which normally I reserve for you, but it's been pretty challenging even for my pre-AP students, so I'll cover it now. The problem is that I'm going to rotate a point A about point B, so it's going to be churning one way or the other. And it says that there's a point when x is 1 that will match the rotation. I don't know what the y-coordinate is, and my job is to find out the y-coordinate. So if I'm rotating it where x is 1, well, one point I can think of is 1, 0, right here. And then you can go 1, 2. You can just keep, basically, if I'm on this line where x is 1, the main thing is that x is 1. I don't know what y is going to be. So I should be able to rotate my point somewhere around here. And the important thing about rotation is that the distance is preserved. Like you can see, this is too far away. That doesn't look like a rotation around B, does it? It looks more like a rotation around somewhere down here. This one would be too close, I think. In fact, if this was at 1, 2 roughly, it would only be 12 units away. So I'm guessing it's going to be somewhere in here. Okay, so my point's somewhere in here. I'll just move that point down here for now. How far away should it be? Well, I need to find the distance from A to B. Well, the best way to do that, the easy things I can count are the vertical and horizontal distances. So I'm going to show the legs of a triangle and where they intersect. I did a horizontal segment and a vertical segment, and they meet at this point, which makes sense. If I go straight down, the x-coordinate better stay 8. If I go straight across at the same height, the y-coordinate better stay the same, and it's 2. Well, from 8 to 13, you get 5. From 2 to 14, you get 12. Well, then I can calculate the distance between A and B using the Pythagorean Theorem. So I have 5 squared plus 12 squared equals basically c squared. Square both, I get 169. Take the square root of both sides, and I end up with plus or minus 13. For length, we are normally talking about positive values. So you could have also done this using distance formula, and it basically would give you the same idea. All right, so now I know the length is 13, so I really don't need those legs anymore. But by the way, notice the advantage of doing this on the graph is it's easier to see Pythagorean triples, which are very popular in geometry problems. We love the 3, 4, 5 triangle, and we love the 5, 12, 13 triangle. So let me go ahead and hide the legs, and I'm going to keep the distance. And I'm going to go ahead and connect this point B to this line over here. Well, when I connect it, I see the distance from B to this line, if I go straight across, should be 13. If I raise it any more, it's 12 instead of 13. If I raise this any more, I know I need to be either somewhere up here or somewhere down here to be 13. Well, how can I figure out what this could be? Well, I could actually remember my Pythagorean theorem here and say, wait a second, I've got a leg of 12. This is supposed to be 13. How big would this side be? Well, that means it should be a 5 because 12 units. So I would move this point so it would be roughly right about there. 2 plus 5, 1, 2, 3, 4, 5, lands at 7. So let me show the circle, and if I drag this point, it would be right about there. So the answer for the y-coordinate is 7, basically taking this 5 and adding it to that 2 right there.